This is a very elaborate algebra geometry problem. However, it can be solved just following methodical steps. Although it looks like a lot of busy work, it is fairly easy and straightforward. The area of an octagon is given is 2a squared, 1 plus the square root of 2, where a equals any side. Now, in this problem, we're given that this octagon has a perimeter of 32 meters. That means 8 equal sides equals 32 meters. So in order to get an individual side, you divide 32 by 8, and of course, you come up with 4 meters, each one of the sides. And so literally by just placing that 4 meters here into this formula, we're able to see that the total area of this octagon is 32 plus 32 square root of 2. Now I'm using this notation here to mean this little bracket sign here over 2, SQRT square root of 2. It's just a notation for quick analysis. All right. So we know what the perimeter is, we know what the area is, but this question is asking after Bill, I believe, picks a vertex and puts 2 line segments in it in the interior, he converts this octagon into 3 quadrilaterals. And the important term here is quadrilateral. That means 4. So each one of these areas here has to have 4 sides, and they do, 4 sides. Now, what we can do next is basically find the areas of these 4 sides. Now, the area of the 4 triangles, these corners here, are very special in the sense that these are 90-degree, 45-degree, 90-degree right triangles. And with that, they have a special relationship, these sides here to this hypotenuse 4. And the ratio is 1 square root of 2, 1. So in other words, what you're doing is you divide this hypotenuse by the square root of 2, and you get 2 square roots of 2. That is the length of these sides of this triangle here. Whether you go this way or that way, it doesn't matter. Those sides are equal. And so what we're doing, we're finding the area of those 4 triangles is going to be 4 times 1/2 the base times the height. So it's 4 times 1/2 square root of 2 square roots of 2 times 2 square roots of 2, because that's the base times the height. And so when we do that, we come up with 16. It multiplies out, you express it, the value, the area of these 4 triangles is 16. Now, what about the 4 rectangles? There are also 4 rectangles here, 1, 2, 3, 4. The area of the rectangle is base times height. Remember, the base is the side of the triangle, 2 square roots of 2. The height is going to be 4 meters, and we got 4 of them. So when you do that, you multiply this out, the expression is 32 square roots of 2. Okay? So we got 32 square roots of 2, and we also have 16. We got the area of the triangle, the area of the rectangle. The final is the area of the square here, which is a perfect square. 4 squared is 16. So we got 16 plus 32 square roots of 2 plus 16. And you find out when you add all that up, you get this value here, 32 plus 32 square roots of 2. However, the problem is, what's the area of these? Area 1, area 2, and area 3. All we got to do is sum the pieces, sum the parts. Okay, and there I'm showing you 16 plus 16 equals 32 square roots of 2. Sum the parts. Quad area 1 is 2 triangles and 1 rectangle. We've already done this computation, the 2 triangles. There's the 1 rectangle, and we get 8 plus 8 square roots of 2. See, right here, quad area 1 is 2 triangles here and this rectangle. Okay, quad area 2 is the exact same thing. It's on the opposite side, so it's going to have the exact same value, 8 plus 8 square roots of 2. All right, and then finally, quad area 3 is the middle area there. The middle area has 2 rectangles and the perfect square. 2 rectangles and a perfect square, you get 16 square roots of 2 plus 16. When you add all of those up, the area equals 32 plus 32 square roots of 2, which we found at the beginning using the area of an octagon. So we just confirmed the 3 quad areas, you're checking your work, equals the final area of the octagon. And so that's it in a nutshell. In 4.5 minutes, we were able to go through that, but it took longer than that to prepare, but enjoy. So you can see the 3 areas and the how they're computed. Thank you.